Hello, everyone. Welcome. My name is Kübra Zengin, and I'm the regional lead for North America Developer Community Programs at Google. Thank you so much for joining us today, and welcome to Between the Brackets. So feel free to introduce yourselves in the chat, and we would love to know where you're joining from. And while you are doing that one, I would like to kick it off with an introduction to Between the Brackets. So Between is a monthly web series where we host experts and Googlers to talk about niche topics on Google products and technologies. And you can check out the website for more information on the schedule and topics specifically that you're interested in. So we will cover web, Flutter, Android, Firebase, Cloud, and AI ML themes this year. So we are now in the Firebase and Android theme. So we are thrilled to have you join us today, and we hope you all enjoy the show. But housekeeping for today, I will just talk about some of the important items here. The first one, as this is a great guideline for all of our events, I would like to remind you all to be excellent to each other. To that extent, please follow all the community guidelines on our website or the links we share. So secondly, add your questions to the chat, and then we will just get your questions in a timely manner for our speakers. And lastly, we are here to help with your all questions, like either it's related to speakers or not. If you have any concerns or questions, you can share with us at btb-team@google.com that you see on the screen here. And with that said, I will just get it started. So today's episode will host two amazing experts on their field to talk about Firebase. And you can ask questions, like I said, during the show directly in the comment section. So that way we can see your questions and then we will reflect on the screen and our speakers will answer those questions. And I will maybe, without further ado, just introduce Artur and Etienne, who are our Google developer experts on Android. So maybe I will have them introduce themselves in the first place while I'm just speaking. So thank you so much for joining us today, Artur and Etienne. And then I'm looking forward to having you, just kind of take it forward.
Sounds great. Thank you. Probably let me start. My name is Artur. I work as a director of Android engineering at Squire, and I've been a digital nomad for about 5 years. Recently, I finally settled in Canada, Toronto, and I like it pretty much. I'm a Google developer expert on Android. Etienne?
Hi, so my name is Etienne Caron. I've been an Android developer for 10 years and in the industry for 20. Google developer experts in 2015. I'm currently entrepreneur, self-employed for a company called Canestruc Incorporated. We do Kotlin programming on multi-platform. Before that, I was with Shopify on their mobile team as a staff developer. Before that, another stint at Intel Security, working on a password manager there. And yeah, that's about it for me in a recent experience and all that.
Sounds good. So yeah, today we are going to talk about MVU, MVI, about how can you utilize different Firebase products with it. And basically here is an agenda. First of all, can you write in the chat, do you work or have you worked with MVU, MVI? Did you like it at all? And just in case, because we understand that there may be different people, somebody haven't worked with these technologies yet. So basically we will present what is it about overall. We'll talk about a few important terms here. And then we will get basically into the weeds. We'll talk about how to structure a model. And Etienne will definitely share with us a lot of his experience working with real-time Firebase data stores and basically the way how can you stream the data and do everything based on it and stuff like that. So yeah, here is the agenda for today. And again, let us know how proficient you are already in it. So we'll be able to tailor this talk, this presentation, depending on basically our audience. And let's probably start with the thing about how do different apps work overall. Cool. And basically, if we will look at it, what do we see? We have a phone, and basically this phone provides us some touch events. These touch events get into our apps. Our apps do something with these touch events. Maybe it was a click, maybe it was a swipe, and so on. We may make some network request to the server, but eventually our app returns to the phone something like pixels to draw. This is a simplified kind of thing. And when different software engineers looked at, okay, how should we structure the app? At some moment, they came up with this idea of unidirectional flow, and that means that everything should go just like in one way, for example, clockwise, as you can see it here, so that something happens and gets from the phone to the app, then something happens within the app, and basically the phone gets something to display. And if we get into some like a little bit more level of granularity, we understand that usually our views, and I mean, this may be Android view system, this may be Jetpack Compose, basically anything that is able to show something, I mean, our objects into the phone screen so the user understands what's happening. This is happening basically on the phone, and we can call it view. And at the right, within the app, we can say that, okay, we have a couple of important things here. First of all, we need to understand how do we handle these touch events, for example, that, okay, there is a touch event. In other words, there is an action or there is an event. And basically, when this event happens, for example, a click, we want to update the app state. And basically, you see this big block of update. That means that, again, we want to somehow handle the touch, and we get to the model. And the model understands that, oh, okay, the previous state was like this, and the action was like this. Probably I should go to the backend, do something, and show the state to the user. And basically, this state is, again, gets to the view to be drawn. And basically, this is the MVU in kind of 2 words. So you can see that, again, we have view on the kind of the phone part, we have updated model state in the app, and of course the view itself will be handled in the app as well. But just to make it kind of more visualized, more clear, this is one of the way to look at it. And that would be nice and simple if it would be just like this. But actually, you cannot just take, for example, touch and calculate something within the function itself. So it would be like a pure function, if you have ever heard it. And basically, a pure function is a function that always produces the same output for the same input. And that's not always the case when we are considering network, when we are considering database and stuff like that. And again, if we look at this schema and simplify it, so we have a view. This view sends some message. This message gets into the update function. It gets processed, and it creates a new state. This is in the simplest and ideal world. The real world, though, is a little bit more complicated. So in addition to this model view update, we actually have some things that we want to, again, go to the network and send a comment to this network. And then later we receive an update. And for example, if you concentrate again on the left part, the way it can be is that when a user did pull to refresh action, that is a message, pull to refresh happened. This pull to refresh message happens, gets to update. Update function updates our state that, okay, we are in loading, and this is the left part of the loop. But in parallel, we are also sending a comment to the network that, oh, okay, network, please update our data. And this data updates in runtime, and that runtime basically returns another message to update. And then we understand that, oh, okay, the response came, so we should just show a list of items or something like this. And basically here is a full-blown MVU. And at this moment, let me probably stop and give the word to Etienne about MVI.
Thanks. Also, if ever questions come up while we're talking between segments, we're going to try our best to answer them, just to say, sure, for folks who might be curious, right? All right, so here I'm going to talk a little bit about the advantages of unidirectional data flow, because that's one of the things that MVI and MVU have in common. I look at MVI and MVU as like basically spiritual cousins, honestly. So anyway, the unidirectional data flow advantages are definitely shared. The first big thing is there's a single source of truth, right? So that's the idea that your model is the one that holds the state and distributes it, or rather the views subscribe to the model. So the source of truth is always in one spot, and it doesn't get like distributed all around. The other thing that brings that unidirectional data flows bring us is consistency. So any changes that are happening to the model immediately get reflected on the UI side. So that keeps things consistent. Then we also have a clear layer of separation between all of our different blocks or components. So that makes for easy testing. So those are the big advantages. Now, if I move on to MVI and do a quick introduction to that, so the model view architecture, again, similar to MVU in a way, if you look at the high level, you have your model that will get subscribed to, and it has a stream of states. Those states are used by the views that subscribe to the model to update themselves. The views themselves present controls to the user, like buttons and editable text box and whatnot. Whenever a user interacts with a view, that gets converted to an intent, that view event that we call, that we don't see in this diagram here, gets converted to an intent, passed onto the model reacts to that, updates itself based on whatever the user did, and then the loop continues and so on and so forth. All right, so there's actually many ways of implementing MVI. So here, but that's one example. That's my take on MVI. You're going to find a lot of APIs out there, but basically the way I've been doing it in the last few years, for the model, I tend to create a component that exposes a stream of state on the output side. That could be RxJava. In this case, I like the new modern ways of doing things in Android, so I'm using a state flow. On the input side, what we do is typically in the model, we'll add a function like this function here, process. And as you can see, it takes an intent as a parameter. An intent is typed. So what an intent is, it's very simply, it's a function that takes a certain my state as a parameter. That's the current state of the model. It applies some work to that and comes back with a new updated state, a different one. Right, so when we look at the view side, the components are actually pretty similar. On the input side, you're going to have, you're going to be listening onto the stream of states. So you can see here, we're taking the model, we're collecting that, and we have a state. That's a composable function here. So whenever that state will change, the composable function will re-execute and update our view. And on the flip side of that, the output of the view, we have a click listener. So whenever there's a click or some interaction that happens in the view, that will be passed on to a handler that will, in this case, take this view event, convert it to an intent, and pass that on to the model. So that's the short intro to the big concepts behind MVI. One of the goals with MVI is to create very clear boundaries between your side effect heavy API code and the more abstract business logic code. So that helps you when you want to reduce the complexity of your app, and it also allows for much better code reuse. So that's an interesting side, a benefit of all of this. So if you look at this sketch right here, you have a few ways. Yeah. No, actually, I'm getting ahead of myself. At this point, I'm going to take a little break and leave it to Artur to basically define a few terms for us. We built a little glossary so that we can sort of all speak the same language. So I'm going to hand it over now.
Cool. So yeah, as we have already discussed, both MVU and MVI are parts of these unidirectional flow approaches. So they are pretty similar to each other. They have just like some little bit difference in terms of terming, so like terminology, and in terms of how is everything structured. And basically, if you will look at the MVU on the left, MVI on the right, you'll see that we have the same like model and views, and they are kind of the same. We have a little bit different names for the function that basically gets some messages, intents, or updates basically from the app. And in MVU, you can call it message, and some implementations call it actions or even events. On MVI, it is commonly called as an intent. You can see it on the right. And the function that basically handles this is update on MVU and reducer on MVI. And you can think that, oh, okay, basically, but if are they just like the same things, just named a little bit differently? Not really. As with many patterns, they are quite similar. And the biggest and major basically difference is how do they handle the so-called side effects? How do we get to the network, or how do we get into the database, for example, layer? And MVU clearly, explicitly basically says that, okay, there is a side effect, and this side effect, it happens outside of our reducers, outside of our update functions. So basically, whenever a feature wants to create something like out of its boundary, it just sends this comment, or it just sends this side effect, and this side effect is handled by runtime. And I'll show you a little bit of example going forward. But for now, what is important is to understand that, okay, we are talking more or less the same language. So here again, we have our model, and if you will look into different frameworks, for example, RIPS, MVI Core, and other frameworks created by different companies that are creating their own MVI frameworks or MVU frameworks, such as Orbit, for example, then you will see that different items are called differently, even if they have the same semantics. So let's say that we will be calling basically these things depending on their semantics and not depending on like a particular framework or whatever. And again, usually you can see that a model, sometimes it's called a feature. This is basically a place, a class that has the presentation logic. It usually stores the state that, okay, is loading happens, or we show a list of elements and stuff like that. And it works with business logic classes. Again, depending on implementation, somewhere you will see this business logic straight in the same like model feature class. Somewhere you will see that, okay, this model feature depends on use cases, and basically it runs the use cases, and the actual business logic happens in use cases. The part that is almost the same everywhere, that's view. That's basically a class that knows how to represent state to the user. It can be a fragment, it can be activity, again, sometimes it can be a view. The idea is that this view class, it basically gets some state. Maybe it is already defined in so-called view state, maybe it will be the generic state, and it just shows it, again, through Android Views framework, through Jetpack Compose, and different stuff like that. The third part, the important part, is again the intent, or in some places message, action, event. And basically this is a class, or sometimes that's just like an API that you will see in methods. And this intent is usually used when something happens on the app itself, or like any input from the user, first of all. And as you remember, the phone basically provides some actions to the app, and these actions will be sent in terms of like intents, messages, and stuff like that. For example, subscribe button was clicked. This is a typical intent. And this intent will somehow be getting to the model, and model will understand that, okay, my state is A, I've got intent like save, and here is what should I do, here is what should be the next state, and stuff like that. And the last one is basically comment or side effect. This is something required for business logic function outside of its parameters. So again, getting to the database, getting to the network, and stuff like that. And when we're talking about state, and here's a link to the author of this state in Twitter, Katalin Kita, and he basically represented a common question that basically many of you probably have already seen, that, okay, how should I better represent my state? Should the state be just like as option A with the monolithic state, that, okay, we have items, we have loading, not loading, error, and stuff like that? Or should it be created in the mutually exclusive states, like type P, again, success, error, loading, or maybe it should be something else at all? And I've seen that implementation as well, especially in the VVM pattern, when we have granular states with state of one element, state of another element, and stuff like that. And there was a big, basically, Twitter thread where people discussed, okay, should we prefer ABC? And do you know what was the answer? You can try guessing. And I know that we have like, 20 seconds, 30 seconds ping. So I'll wait a bit. Hopefully.
Does it depend? the ultimate answer, yeah. It depends, yes.
That's true. And basically, the Twitter thread kind of shown the same, that there are many different people, there are many different approaches, and each of them has their own basic advantages and disadvantages. For example, with mutually exclusive state, you will get the situation that it will be pretty much verbose, and you will have to have this when statements like everywhere, and to have some duplicated code in different when statements. With option A, you can get some states that are technically should be impossible, that you have, for example, both items loading true and error true. Probably you don't expect to see that in your app, but because this basically state is structured in this way, technically it is possible. And as usual, there is no silver bullet. And just to show you basically how can an MVU feature look like, I've got an open source project. I think that we'll send the link after this talk basically to chat, or we'll attach it to the YouTube page. But basically, there is an app called Movies feature based on this TLM architecture or based on this MVU approach. And again, when you're creating a feature based on MVU approach, the important part, and probably the biggest difference with like MVVM or MVP, is that again you have a clear state. For example, here I have gone with that type A of the state. Okay, we have this loading, we have movies, we have some message. For example, this start typing in a search bar to find a movie. This is basically a message, and stuff like that. Then basically, the important part is that Vue always is able to show basically whatever is your state just by looking at the state. And if we will check out the movies fragment, we see that this render function, it basically gets a state, and this is it. Whatever is state at this moment, the view will be in that state. If the state shows, for example, that it is loading, or that my emulator doesn't want to work, you'll probably see it in state as well. But if there would be a list of movies, that's what I would expect here, then you would see that, okay, basically our state contains the list, and basically next time when the view renders itself, we would see the list. There are messages, again, actions, intents in MVI and stuff like that. And these messages, again, tell us that search updated, movie clicked, and stuff like that. And there is this important part that is logic. And we have an update function. And update function is, again, a pure function. So update function gets us a new message that, for example, something was clicked. It gets us previous state. And as a result, it provides a new state that, for example, we show a loading, and we want to make a network request. Basically, when update function finishes, we have the comments, and these comments, we have the same rule for them as for views. So basically, they should be as simple as possible. So we don't have to test them, basically. It just gets like, okay, repository search movies. And again, it provides the response to the update function. And class of dependencies is just basically whatever is required for comments to work. And that's basically it. And if you're interested in, again, like checking out a simple MVU example, I have a project when I have this written as an MVU. I have it written as a view model, basically the MVVM style. And you can check it out when you have a chance if you're interested in. Thank you. And on this note, let's continue with MVI and how do we structure models. Etienne?
Yeah, I'm just going to tell the audience, and I thought it was very interesting that you showed three different approaches to keeping state.
Sure.
And I like the idea that it depends.
What do you prefer? Yeah.
I personally prefer mutually exclusive, right? But to be absolutely honest, I've used pretty much all three. It depends on the project, right? Sometimes it's much faster to not even bother with like mutually exclusive state if it's a very simple model. You know, I'm interested to know what the audience will think about that, and I'll just keep going with the presentation because I know we have a strict time schedule, right? Just
let me probably like show up one of the comments here now. Tells that.
Oh, we have one.
Okay, can you share the repo? Madusha, I'll ask you to send it, please. And I'll send it to you in Slack at the moment. And I see that Nav told that, okay, I saw first option used in one of the Google samples. So basically you can find these things in Google samples. And I believe that I have seen somewhere mutually exclusive states as well.
I'm happy to see Nav in the stream here. He's from Montreal, so hi.
Oh, cool.
Cool. I'll keep going with our little presentation then. Okay, so where were we? Right. We have a little segment about how to structure models, which is a fairly interesting question because we talk about MVI, MVU, and you could think of it as, oh, it's very simple. There's only one thing, right? You only have one view, one model, and that's like the first way to structure things. Like you can think of your app as really having one model per view. That's really appropriate if you have something like I'm trying to show here in this little diagram, where you have a simple screen with a save and cancel button, right? If you have that, then one model is fine. But what if you have something a bit more complicated, right? So if we're looking here at a list detail type scenario. So we have a list. The list could be pulled to refresh, right? And on the other flip side of that, you have the detail of each of the items in this list. You might need to load more details whenever the user presses on one of the list items, and you move on to that. So that's an example, a bit contrived, but an example where you could end up with two different models for your one screen. Also, you can start thinking about, oh, I might be dealing with a tablet API, tablet app, or a phone-based app, or the same app, just dividing the fragments, right? So if you start thinking about how your app will be structured, and you want to reuse as much code as you can, then yeah, multiple models can make sense. After that, well, the thing to note is that it's thankfully not very hard to handle communications between different models even. Like the example I just shown, you don't really have any cases of multiple models talking to one another. But you could come up with a few creative ways of doing things, right? For example, if you had smaller screens in your app, and each of these screens can actually be edited and saved individually. So you have a tablet or like a really big screen. You wanted to split this UX. Doesn't make much sense, but I'm just trying to sort of get the idea out there. You could eventually end up with one master model that depends on submodels and so on and so forth. The interesting thing is that unidirectional data flow does allow you to handle, this looks crazy, but if you're building your models properly, you can actually compose them together and have a cohesive whole at the end of the story. Another thing I want to touch on is the concept of side effects and model events. So we touched on side effects a second ago, but I have like a little diagram here that I wanted to wait, am I going a bit too far ahead? No, okay. So it's important to mention how to mention these in the idea of structuring your models for the following reason. Like we talked about how a model sometimes accesses third-party APIs outside, and it's a side effect technically, right? Like your model itself should not have side effects, but what it can do is call outside, put itself in a state where it'll be waiting for results, and it sort of isolates the view from potentially side effect type behaviors where things don't lose coherence. The other thing to think about a lot on Android, and that comes back a lot, is how to handle events and model events, I mean. And what by that I mean is like sometimes people confuse a little bit the idea of side effects where your model reaches out to the outside world and tries to load information or save something to a server. And side effects like, oh, the model just transitioned to something different, I need to navigate away from this screen. For example, I saved the record, I'm done, I should quit the screen and go back to something else now. That is not, properly speaking, a side effect. That's more your model notifying the outside world, hey, I've changed, like something happened. That's basically the idea of the event. The model event is something that is not like a permanent state, is that if there's a listener out there that is looking at the model and wanted to know that there's a transition going on, it's a one-time signal. You're there, you catch it. If you're not there, you just lost it, and that's it. So that's useful for navigation, toasts, and snack bars, and so on and so forth. Yeah, let's see. Yeah, that's sort of the idea expressed. I'm just trying to make sure I'm dividing up our segments properly. Anyway, so I'll finish up here. That's basically the diagram of the exclusive states we talked about, option B from Artur's segment just a second ago, right? So the idea is that you can have your closed state, and then when you're loading data, that's when your asynchronous call is going on outside. When you're done, you'd be falling into an editing state where you could be showing and allowing the user to edit things. And ultimately, user presses save, you go back to a state like saving, where you're actually waiting on the outside world. I'm showing this just to show the idea that the model itself is in a coherent state. It's not necessarily side effecting inside of its own little bubble, right? As far as the view is concerned, if we're loading, there is a side effect in flight, right? And technically, we're waiting on some outside API. But as far as the view is concerned, what it's relying on, its single source of truth, is just basically saying, I'm busy right now. And the view can react accordingly. And to go to the idea of the event that I just showed on the slide, the idea is that an event would be something different. It's something that is not a state that you could broadcast on a different channel, if you will. So in this case, my proper state, model state, is on a state flow, and an event can be broadcasted effectively by a shared flow. The difference between a state flow and a shared flow: the state flow has state, it's in the name, right? So there's one piece of information, you subscribe to that, you get that piece of information and any future changes to it. And if you subscribe to an event channel, in this case, you're not going to get a message when you subscribe. Nothing happens. You just get notified whenever something happens and you need to perhaps react. And then things get a lot more complicated if you start from there on Android. We're not going to get into that. But if you start thinking about this idea of structuring your models, you're going to have to think also about the lifecycle of your application. Now, in certain cases, your model might be limited to the fragment or the activity lifecycle. In other cases, if you have a more permanent API, and we're going to see one very quickly with Firebase in a minute, you might want to have that model at the applicative state, because that's where it makes the most sense to live. Anyway, we'll get back to that in a minute.
Etienne, can we get back to like one slide with your state?
Yes,
because
sure.
Here I probably would like to highlight one more thing that many people, many developers often like getting into. Yeah, and when we're talking about this sealed class myState, yes, we have like a nice enumeration of different states that are possible. However, for example, here in your loading, you have loading as an object. But again, in the real life, oftentimes we want to be able to show some data when we already have something. For example, if we are talking about pull to refresh, so we have state loading, that is like initial loading when we don't have any data. Then we have state of basically data when we have the data. And then if a person drag this pull to refresh thing, we want to have a state loading with data. And as a result, basically what I don't like, and I mean what I sometimes find a little bit irritating in this approach be with closed states, is that, okay, we have loading that can or cannot have data. Again, for initial and non-initial state, we have error that can actually be, for example, after loading, you may be able to still have the data that was, for example, cached before, but you have an error that this particular network request failed. So you have a state that, okay, has both data and error, and then it becomes a little bit messy. So yeah,
that's a really great point. Of course, this is very simplified code, right? But sure. Yeah, I've seen all the different cases you talk about. In my experience, I find it really depends on the actual UX you're trying to build. You've described a case, a very good one, right? You want to show some information while you're loading. Yes, you're going to need some sort of data class. In this case, I'm showing this works. An object loading will work when you have a very simplified thing, when you're not expecting it to take a long time. So that's a thing we've talked about in preparing for this show, is that what's interesting with MVI and MVU, it's not that it gives you a silver bullet, right? Is that Definitely. It gives you a very nice toolbox. And at the end of the day, what a lot of people sometimes forget when they try to apply architecture rules in a very rigid way is that depending on what UX you're working with, and we're going to see that in a second with Firebase, depending on the API and the backend you're using, you're going to have to build your models and your structure fairly differently. Anyway, that's I think that was a great point for you to bring up.
Thank you. And we can proceed.
Yeah. Actually, am I next on this again? Yes?
Yeah.
All right, cool. I'm just looking at our structure document, making sure I'm not so yeah, we're going to be chatting. Right, so we're going to be going over basically the different offerings that Firebase has as far as data is concerned. So the big ones, of course, Firebase is a whole platform. If you remember, originally Firebase was a real-time database, and that's it. Before Google acquired them, I want to say 2016 or something, and then it became this whole platform that offers a ton of things. We're going to focus mostly on the real-time database in the Cloud Firestore right now. So the difference between the two, that's often something that comes up if you don't have a whole lot of experience. I used to have a lot of trouble differentiating the two. But effectively, the real-time database, it's in the name. It's a bit more focused on quick millisecond responses. So if you want to build some sort of shared experience, a bit of a game, and that when people write to the database, that information is synchronized across all the devices, real-time database is sort of your first pick. It has really nice offline support as well. And then the problem a little bit with real-time database is that it scales horizontally, so manually, effectively. If you want to scale to a much bigger scale, you're going to need to start creating multiple real-time databases. There's a point where you reach a certain size, one instance simply will not work. You're going to need to create more instances and sort of shard your model across those. Whereas Cloud Firestore has a very flexible data structure, meaning that it has a bit more leeway as how you can define your data and how you can map out your collections and all of that. We're going to talk about that in a sec. Whereas real-time database is effectively just a JSON tree when you store your data in it. Cloud Firestore also has, in my opinion, again, that's like, it depends, but it has better, more expressive querying. So if you're really looking to do extensive queries and dig into the data set, Cloud Firestore might be your better option here. It has automatic scaling, which is a big thing, effectively meaning you just throw more data into it, throw more users at it. Eventually, you're going to hit, obviously, pricing issues, but it can scale as your user base grows and your data set grows. The real-time and offline support is there, but it's maybe not as user-friendly as real-time database, I would say. So those are the big differences between the two. There's obviously more detail at the link I provided on that slide. Very quickly, real-time database, as far as the pricing goes, that comes back a lot because everybody, like, a thing I keep hearing about is, ooh, Firebase is expensive. I always find it funny because in my own experience, like, I've used the real-time database in a very professional setup at Shopify. We had a fair amount of users. Admittedly, not a ton of data was being transferred, but I think we did fine with like multiples of tens of thousands of users per month, and we never really hit much more of the limit of the middle tier plan they had back then, which was like something like $50 a month. But there are instances where you can run into trouble if you don't watch out how you write your app. So Firebase real-time database, simultaneous connections, like, you don't have a whole lot if you don't pay. You have really a nice amount if you do pay. You see the numbers here. I'm just not going to read them off the slide. Then Firestore, compared to that, is a bit more structured. So the numbers obviously not the same because the service is very different. But we're talking about stored data, network egress, and document read, write, and deletes. And those are more priced on the Google Cloud side of things. Ironically, when people tell you, oh, watch out with Firebase, the cost can get up there, they're usually talking about the Cloud Firestore stuff, which might not seem coherent, right? They'd be like, well, that's odd. Isn't Google Cloud pricing more competitive? And as far as I understand, yes, it is. But effectively, with Firestore, I think there's more foot guns of sorts that people run into. Like, I quickly looked at a few YouTube testimonials lately, and story usually goes the same. Oh, we configured our app wrong, and traffic went off the rails. And usually the story ends with, and we talked to Google, and they were nice enough to help us fix it and reduce the fees. So anyway, just a little anecdotes here. Right, how does the real-time database work? I touched on that. It's a JSON tree. Nothing much to say here. The difference with Cloud Firestore more works with documents, which are effectively key values and maps of key values in one document. And then the next sort of tier of organization there is that you have collections of documents. There's a lot of rules and ways of sort of interacting between that. And I looked into it. I was like, oh, should I talk about this? And I was like, yeah, I only have a few minutes to talk about this. We don't have 2 hours just to talk about the two different offerings. So go see that video right there. Tremendous job. Like, I find the Firebase folks have done really nice work in sort of explaining the structure and everything. So go check that one out if you're not familiar with it yet. And it's a nice listen, and it'll be very clear to you afterwards. Other thing that comes up a lot in discussion for Firebase when we talk about the database is conflicts in offline. How does that work? And I find that's one of the really nice things about Firebase. Both solutions are really interesting in that way. You can fairly easily on Android write an app, enable offline mode, and you just keep working. Your app code, your logic code will not even need to think much about, am I offline or online? For anybody out there that has had to write like a connectivity detection bit of code in the last years, will definitely know what I'm talking about. This is really painful. So in this case, it's nice because you're talking with Firebase offline. Well, you don't need to care about that. You just have all your data offline in the Firebase instance that you have on your device. You write to it, it fires events off to your code. You just operate with it as if you were live. And when you come back online, the Firebase instance will take care of synchronizing with the backend. Of course, there's a lot there. Synchronizing with the backend is not necessarily simple if you're coming back from offline. The two basic things to remember is that you can have easy writes that will eventually go out to the server, and that can lead to problems if you do it very naively, because you're effectively able to write over some things that might have been done before. If you do it a bit more smartly, you're going to have mostly transactions that are being used, but then that comes with some caveats. Again, we're not going to do a deep dive on that, but the idea is that in the real-time database scenario, you can actually create transactions that are going to get queued up and executed later when you connect. You might lose those transactions if your app goes offline, though, so there's downsides to that. And on the flip side, if you're using Firestore, typically from what I read in the documentation, and quite frankly, I haven't used transactions in an offline scenario with Firestore, but effectively what's supposed to happen is that they will simply not work. They will fail. So if you want to do transactional work, you just handle the fact that it's disconnected right there and then and deal with it. Right. So after that, well, what to think about? Yeah, I'm just going to double check I'm not overstepping my little section here. Artur can double check on me. Multi-snapshots versus...
Depending on where you are at the moment.
Yeah. Actually, you know what? I think that segment is for later, so I'm going to stop right now.
Oh, okay.
But
cool.
Yeah.
And yeah, I've seen a question from, I mean, probably that's a nickname, CPU Easy. And yeah, the person asks, can we explain a state flow versus a shared flow again? Aren't both hot flows? And yeah, probably let me chime in. So yeah, both are hot flows, and kind of the shared flow. Again, if you look into the documentation, that's a more generalistic kind of version of the state flow, because state flow always by default returns you the last one basic element, and you can subscribe to the state flow and get the same data when you are subscribing to the same flow from the different things, and so on. However, that's not actually the case. I mean, that's not really important in our implementations. And when we are talking about state flow or shared flow and why one or another would be used in, for example, these MVU flows, again, as a reminder, we have this unidirectional flow, and that means that, first of all, somehow view should be subscribed to a model. So when we are updating state, the view understands that, okay, the state has updated, so the view should update itself. That's one. And second part is that somehow we need to move all the events or actions or intents from the view, basically from the user, back to the model. And this may be like an example of another flow. And in theory, we could have used like shared flow there, probably with repeat count equal once, because if you remember like what a hot flow is, basically that means that at any given moment you can subscribe to it and you will get the events going forward. But the issue is that when the view has just subscribed to the model, if for any reason there were already some events, I mean, the view still needs to know what was the latest state so it can represent it. And that's why basically we are using the state flow, because state flow always returns the latest basically element that was emitted to the state flow. And this allows us, so whenever we are connecting to model, we know what was the latest update. And that's the important part, I guess. Etienne, do you have anything to add here?
Yeah, basically what you said, I guess like the thing to think about too is that they're both hot flows. State flow is technically built on top of shared flow, right? With a few little niceties added on top to sort of make threading nice and concurrency not hard to deal with. But effectively, a shared flow at the basic level, if you configure with a cache of 0, you can tell a shared flow how many events it should replay. So you could technically say, replay the last 5 events for any new subscriber. That's a thing you can do. There's cases where that's useful, not necessarily in an MVI, MVU architecture, but So effectively, if you think about that, like really the core difference between the two, again, a bit like Artur just said, shared flow configured at 0 buffer is effectively just a radio. You turn it on, you're going to hear what's going on. You're not going to know what happened 5 minutes ago. You have no clue. So you can only react as a view to whatever comes up. So that's the event channel of sorts, right?
Mm-hmm.
That's actually fairly rarely used, because if you think about it, there's not that many view APIs that are event-based in our case.
But
And
actually,
the state,
actually, one of the kind of examples from my experience is that I've seen shared flow to be used for the things that you have called model events. That's, for example, navigation. Because when we are talking about state flow, for example, if we would put the navigation events to state flow, and we may come into a situation that basically, for example, a view was restored, and it has that event as a last event, or maybe some toss that, okay, error happened. And if you just like replay the last element, for example, error happened, it may not be the true, because the view just like recreated and actually nothing happened yet. And that's when we may want to have this like radio style hot flow without any repetition.
Yeah, navigation toasts, I mean, when I say they're rarely used, actually, it's only 2 cases that usually come to mind whenever I think about event-driven APIs. There's probably more, but like I'm not being very creative right now. And then the state flow for the question, right? State says it. Like, it's a bit sometimes hard for people to reason about, because we talk a lot about reactive programming and functional programming. Technically, the second you have state in the name, you're not doing functional programming, right? But you are doing reactive programming. And so your state flow just is basically a shared flow with one very specific item in memory. And like you said, Artur, like you need that if you're going to display the current state of things, right? You have one model, if 3 different views need it, because the different views needs to show what's going on, your model's not going to reload every time necessarily, right? So you need that memory aspect to things.
Sure, completely agree.
Yeah.
One more thing that we wanted to discuss is basically, again, about this state and about working with real-time database, or about working with Firestore, is basically how are we organizing work with this? Because first of all, when we're talking about some, I don't know, like classical examples, working with any network, working with like almost any database, except of the real-time database in Firestore. Madhusha, can you please share my screen again? Cool. Yeah. So, and again, you can see this classical example in my T architecture, basically sample. And probably you have done something like this a lot of time. So again, you have some state, and again, it may be an explicit state with these movies. It may be even an MVP pattern when you request a list of movies, and then you send this list of movies back to the view. But again, the idea is that you are getting this data and you are having it in memory. So for example, here, in order to get this list of movies, when everything starts, we have so-called initial update. And this basically initial update happens when the feature is just created, or when the model is just created. And eventually, when we are doing, for example, search updated, so user enters, for example, a car or whatever, we want to send a network request. So basically, what do? We get into the update function. We see that, okay, search updated happened. And again, as a reminder, the update function is a pure function. So it means that even if I send like this thing 1,000 times, it will always produce me the same results for the same input. For example, the message is again that search has updated. And you can see that that's just like a simple data class with a query. And the result, and I mean, the state is whatever state at that moment. Maybe we are already showing something, maybe not. But the important part is that, again, when we have this search update, we have a kind of both business and presentation logic here. For example, here I have a logic, okay, what should happen if query is empty? If query is empty, we do not do any network requests. We just show a message that start typing in the search bar to find the movie. Otherwise, if query is not empty, basically we are checking out, okay, when was the last time when we have sent this request? And this basically, this is the way how can we handle the throttling. So for example, if the time less than 500 milliseconds, then we are not updating state. We are returning the same state. We are returning no comments. So basically that means that nothing changes. And only if the query is not empty and duration is more than 500 milliseconds, then we are updating the state. And again, what should we do when we have sent a network request? Of course, we need to say that, okay, loading is true. And as soon as we are returning from this function, basically the view, because it's subscribed to updates of the state, it will see that, okay, loading equals true, and the view will understand that it needs to show some kind of loader. And simultaneously, again, we are sending a comment get movies. And you can see that this comment, I mean, each is just like a plain old Java class, or in this case, that's a data class. And this data class gets sent to runtime, and basically each is handled in runtime. So the actual network request doesn't happen within the update function, and this is what's important. And as a result, basically, our update function can never break just because, for example, there is network or whatever. And we can unit test it, and we can be sure that it works as expected. And again, when the real thing happens, it happens within the comments that we have get movies. And this get movies comment, it sends the network request, and afterwards this sends the new message movies response. And our business logic, our update function, understand that, okay, for example, we have been in a state when we were in loading and we had some data, or we didn't have any data. And what should we do when movies response comes? And again, we check out the update function. We see that, okay, when the message is movies response, we are handling it by, again, depending on the type of response. If there is a failure, we are showing a message. If there is success, we are basically updating the data. And again, depending on the type of data, for example, maybe the message is success, but we don't have anything to show because there are no movies for this query. Then basically it will tell that, okay, loading is false, movies empty list, and like no results matching your query. And in the case, again, if everything is well, then we will update our state. And again, as soon as we have updated our state, our latest state becomes that, okay, it's not loading. The list of movies is basically here, and the message is empty, and the view receives this message. And I mean, I guess even you, without like knowing how the whole system works, can easily understand how should the screen look like when is loading equals false, movies, I mean, equals to something, and messages equals to nothing. You will expect that you will see a view without a loading and with some data. And that's basically what will happen. But again, the important part here is that this state itself, each is stored somewhere. It's stored in actually a state flow, as we've discussed before. And for example, if a view recreates, it will just get the same state that it used to get like last time. And again, we will see the state restoration without any additional kind of actions. And that's nice. However, this approach differs a lot if you decide not to have like this state in memory. And this is, again, the thing about having state in memory and having a separate like endpoint for REST API. However, what Etienne shows and what Etienne talks about, what if instead of having like this explicit state, we would just kind of use our database as a state? What if instead of sending all of these things, we would just say that, oh, okay, put data, get data, or something like this? And I think this is something that Etienne can drop a few words basically into.
Yeah, exactly. So that's like the big payoff of Firebase, really, at this point, because everybody must have seen how we handle state typically, and there's a fair amount of work around that. So let me just show quickly, like, what's the potentially concept. Like this UX doesn't necessarily work for everybody, right? So the idea is that you have your typical UX where you're going to fill out your information and you can press save or cancel, right? That's most of the screens we see on the web. And then with Firebase, what it enables you to do, and this doesn't always make sense, right? I want to caveat that, but what you are able to do with Firebase is simply edit in place. So if you see the little diagram on the right that I have here, technically what I'm trying to illustrate is that you can make a setup where every time an edit happens, you push it to your model. If your model is backed by Firebase, your model will basically offload the work directly to Firebase. It won't even try to update its own internal state. It will take that change, give it to Firebase, and on the flip side of that, the model itself will subscribe itself to Firebase as a third-party data source, right? And it will be notified whenever that updates. So what does that look like in code? I have like here, okay, so don't be afraid. This is a more complex example, but I want to point out one thing here. And if you just, we'll just do this very quickly. So I'm using a laser pointer right here to illustrate one thing. So if you look at our mutable state flows that we have here in the state flow, so the idea is that what we're creating with Firebase is typically a subscription to Firebase to update ourselves, right? So this whole block that you have here, the init block right there, the idea here is that you can simply say to Firebase, hey, I want to have live updates for my, in this case, my club maps. Right? So I have a list of clubs. And so I want to be notified of this. So you subscribe to Firebase. And admittedly, this is a more complex example. Typically, a one-liner would be sufficient to subscribe to a database source in Firebase. But you subscribe to it, and all your model will do is republish this as a state flow. And on the flip side of that, whenever you get an intent to change the model, you won't apply the changes to the model yourself because Firebase has become the source of truth. Your view doesn't know that, right? Nobody that uses your model knows that. It's an implementation detail, but technically, that's what's happening. So what you will do when you get an intent to change the model is you will rebundle that and pass it off to the third-party library, in this case, Firebase. And Firebase will take care of doing its magic. If you're offline, the benefit is it will save directly on the offline database and will fire an event right back to your model saying, hey, that changed. So your model doesn't even need to be aware of, is there a connectivity? Is this a local change? We don't care. The model updates and your view will update if it needs to. Now, what you see here is a little bit more of a complex example because in this case, I took something out of one of my own apps where I'm accessing a secured section of the Firebase real-time database. So I needed to be able to say, okay, I need to access something based on the signed-in information right there and create a reference, a query that will load this JSON node off of this authentified section, right? So I need to have a user. So this chain is a little bit complicated. And I find that another complexity source with Firebase, which is a bit of a downside, although it's still somewhat of a benefit if you think about it, is that you need to flatten your database in Firebase, right? There are certain rules and best practices you're going to want to follow for your model. And once you do that, you might end up with 2 or 3 real-time sources of information that you need to merge together to present to your view in your model. So this leads to fairly complex chains, right? For me, I'm used to this stuff, so this doesn't seem like a crazy chain. But admittedly, that's because I'm used to it, and it might be better. So I'm going to end with a mention of a possible future, actually a future that is available now on Android. So a shout out to the nice folks at Square, or Block, is it now? I don't even know anymore. Anyway, the people at Cash App have built this really neat little library called Molecule. So it's available on Android only for now. I believe they intend to make that a multi-platform lib. And what this does, it allows you to basically take the kind of code I just showed you, right, to build a Firebase data source. And instead of really building a chain out of it, you can use the compose way of doing things and declare imperatively what you want out of your data source. And Molecule will help you build those flows in a much easier way. Anyway, that's not something I can talk about to lengths here because, you know, limited time and all that. But I encourage people to check it out. Like, I found out about it like not so long ago, and I'm really keen on it. Anyway, I think it was a piece of information I wanted to share with everybody. And that's about it for the presentation part. I don't know how much time we have left for questions. Like, I'm available for a bit. But Artur, do you have anything to add, or did you see any questions?
I don't think so. I mean, of course, I can go on and on, but let's say, see if Madusha, or Kubra have something to add. Probably, yeah, just like a few words, just like kind of as a recap. So yeah, basically today we have talked a bit about MVI, we have talked about MVU, about how can you do all of this like magic on Android, and why you may consider doing it. Yeah, we have talked a lot about Firebase, Firestore, real-time database, and why can you basically choose to use it. And yeah, definitely thank you for your attention. Cobra.
Perfect. Thank you so much, Artur, for just making, the summary of this session. And then thank you so much for joining Etienne and Artur all together. And then this was a great session once again. And then we are looking forward to hosting you again, maybe in the future. But yeah, this was really, really good for our audiences. They really liked it, all the questions and, you know, like all the topics and all the actually presentations. Thank you once again. And then with that said, I will wrap it up with some sort of logistics from now on. So let's kind of wrap up to share some of the details about Between the Brackets. So thank you so much, everyone, for joining us today, and hope you all enjoyed this episode. We would like to kindly request from you to fill out the feedback survey in the follow-up email or the link below here on the screen, that we can improve the show along the way. And you can use our hashtag Between the Brackets to share how this show was for you. So we are going to have our next episode next month, and then we will be giving you more information if you already signed up on the website or subscribe to our channel on YouTube. And please, please, please let us know if you have any questions via like b2b-team@google.com. And with that said, we are looking forward to seeing you next month. Till then, take care.